Now coming to the next chapter, that is organic compounds containing nitrogen. We can select organic compounds containing nitrogen. So in this particular chapter we are going to study about, the first is your nitriles and isonitriles. Then we are going to study about amines and diazonium compounds. Alright, so basically there are 3 chapters which we need to study in this particular chapter. Okay, so now starting with the nitriles and isonitriles, which is also called as cyanides and isocyanides. Nitriles is called as cyanides, CN the functional group, and isonitriles are called as isocyanides, whose functional group is NC. What I said, that is the first is CN, which is called as nitriles, or the common name is cyanides, and the second one is NC. This is coordinate bond, we can say that here, coordinate bond. So it is called as isonitriles or isocyanides, so to say. Alright, basically these two, they are believed, it has come from, these two compounds we have got it from, that is hydrogen cyanide, which shows tautomeric form. Alright, these two compounds, that is these two functional groups rather I should say, we have got it from hydrogen cyanide, which shows that is a tautomeric form, we can say that. Now how hydrogen cyanide shows a tautomeric form, we can say that HC triple bond N. Alright, it shows a tautomeric form. In tautomers, the isomers are in dynamic equilibrium with each other. So H N C. So this is the tautomeric forms. As a result, the cyanide group is an ambident group. It is an ambident group. Ambident means what? In which we have got 2 donor sites. Here the nitrogen, here the the carbon atom is a donor site, here the nitrogen atom is a donor site. That means the carbon atom can be attached to the alkyl group. Here the nitrogen atom can be attached to the alkyl group. So that is called as an ambident. Alright, that is ambident group in which we have got 2 donor sites. We can say that, as you can see very clearly. That is, we have got 2 donor atoms. We have read about the ambident nucleophiles in coordination compounds. I have told you in details about it. Alright, so hence we can see that this compound, that is hydrogen cyanide, it is which exists in 2 tautomeric forms. From there we have got it, this is cyanides and isocyanides, which is called nitriles and isonitriles, so to say, we can say that. Clear? So as a result, we can say that there are several, that is organic compounds, when the different alkyl groups are attached to it, we can get the several organic compounds. Due to the presence of the ambident group, we can get the several organic compounds. For example, if I am having CH3CN, it is known as methyl cyanide. CH3CN, look here, it is CH3CN is methyl cyanide, common name. But the IUPAC name is 1, 2, it is ethene. Root word is eth, 2 carbon atoms. Ethane nitrile. Ethane nitrile, we can say that. Similarly, we can say CH3NC. CH3NC is what? Methyl isocyanide. Methyl isocyanide or methyl isonitrile. The common name is methyl carbyl amine. IUPAC name is methyl carbyl amine. We can say that. Clear? There is methyl isocyanide, the common name. We can also say the IUPAC name as methyl isonitrile or methyl carbyl amine. This is also called as carbyl amine, we can say that. Similarly, as you put the alkyl group to it, you will be getting the different names. Alright, as you put the alkyl group to it, like we are having CH3, it's methyl cyanide. We can have C2H5, methyl cyanide. The common, the IUPAC name will be propane nitrile. In this way, we will be getting the different IUPAC names, you will be getting it accordingly. Actually, it is also derived in this way from the acid. Alright, that is, from the acid we remove the ic and we add the word ic acid, we removed it, and we add the word O-nitrile. Alright, now let me give you an example to you. Got it? So it is believed, it is seen that, not believed rather, it is being seen that cyanides upon hydrolysis gives carboxylic acid. Alright, you have read it in carboxylic acid chapter. You will be reading in this chapter also upon when I will tell you about the chemical properties. At that time you will study that cyanides or nitriles upon complete hydrolysis will give you carboxylic acid, so to say. For this purpose, the terminal ic acid from the carboxylic acid, ic acid, is being replaced by the suffix O-nitrile, and we get the name accordingly. For example, here you can see that CH3CN upon hydrolysis, that is 2H2O/H plus, acidic hydrolysis, will give you CH3COOH plus ammonia, the secondary product, so to say. We get it. This is a reaction. In general, we have studied in the preparation of that is what you can say carboxylic acid. We can say that ammonia you will be getting it. Let me complete the reaction also. Otherwise, you may think that why the reaction is not complete, because I am talking about the name. For that reason, I am not interested in the reaction. Okay. Anyhow, I have completed the reaction. You can see it here. So here, what you find is that this is known as acetic acid. Acetic acid. What I said you replace ic acid by O-nitrile. So what is the name will be? Acetonitrile. Acetonitrile. We can say that. Clear? In this way, this is what you can say. This is not the IUPAC name. It's a common name. The naming is being done. But I am saying it's a common name. We can say that. But in IUPAC we name it as alkyl nitriles only. As I said you already, in IUPAC it is ethane nitrile. Alright, that is another way of naming, that is a common name, as I said it to you. Clear? So in this way, the naming is being done: ethane nitrile, propane nitrile, butane nitrile as alkyl group. That is, a number of carbon atom increases in the alkyl group. The naming is also changing accordingly. We can say that. Alright, we have studied already in class 11 in nomenclature. Just once again, I am revising this part so that it will be easy for you to understand it. Alright. Similarly, the isocyanides also is being named accordingly. We can say that, like CH3NC methyl isocyanide, we can also call it as methyl carbylamine or methyl isonitrile. We can say that. Similarly, if it is CH3CH2NC, it is said to be as ethyl isocyanide or ethyl carbylamine or ethyl isonitrile. We can say that. I hope you understood this particular thing. Now, in this way, the naming is being done. Alright, for nitriles and isonitriles. Now, coming to the structure. Now let me tell you one thing about the structure is that C triple bond N, the bond length is the least because it has got triple bond. The bond length is the least compared to C double bond N, compared to C single bond N. Alright, if you see the bond length, C triple bond, again I repeat, if you see the bond length, C triple bond N is having the least bond length due to the presence of triple bond compared to C double bond N, compared to single bond N. Now here this is nitriles. Here C double bond N means another will be your NH. Alright. And C means here any alkyl group, of course. Understand it. An alkyl group will be attached to it. Understood? An alkyl group will be attached. Mind it. And here it is C single bond N means other will be your NH2. So here it is nitriles. Here it is imines. And here it is amines. So nitriles is having the least bond length compared to imines, then amines. I am talking about the bond length, mind it. This is having the least bond length, triple bond. Compared to imines, C double bond NH is imines, you know that. And compared to amines, C single bond NH2, we can say. Clear? So in this way, the bond length, it differs in this particular manner, we can say that. Clear? Now, here the carbon atom, it is sp hybridized. So hence, nitriles and isonitriles, they are linear in nature. Alright, it is sp hybridized. But suppose when I say CH3CN, here this is sp hybridized, but this particular carbon is sp3 hybridized. Very clearly, it is sp3 because carbon single bond. It is sp3 hybridized. This is the formula of acetonitrile. Just now I said it. Or we can say it is methyl cyanide. Or you can say it is ethane nitrile. The IUPAC name is. Alright, clear. And the compound is linear. The bond angle is how much? It is 180 degree. The bond angle is 180 degree. It is linear in nature. Alright, clear. Due to the presence of sp hybridized carbon atom in the functional group, so to say. Clear. So in this way, we see that is they are linear in nature. About the bond length I have said you. Alright. So this is about your structure, so to say. You came to know. Now, next is what you find is that we will see the preparations. Preparations of nitriles and isonitriles, we will see it. How can you prepare nitriles and isonitriles? Now we can prepare it from alkyl halides. It's very important, which I am going to say you now. It is very important. We can prepare from alkyl halides. Alright. Now when you prepare from alkyl halides, you will get two different compounds. Means if you take what you can say, that is the same alkyl halide, but if you take two different what you can say nitriles, two different nitriles, means if I take potassium cyanide or sodium cyanide, I will be getting what you can say nitriles as a product. Means I am talking to you Rx plus KCN alcoholic will give you RCN plus Kx. The reaction takes place in this way. R is positive compared to X. We know that. X is more electronegative compared to alkyl group, that is carbon. And potassium cyanide is an ionic compound. It dissociates into K plus and Cn minus. In presence of alcoholic medium, it acts as a reducing agent. Clear? So here K goes with what you can say X. Very simple. Positive and negative. And R goes with Cn. R goes with Cn. We can say that. Upon slight heating, we have to heat it slightly, you will be getting nitriles. If you take a sodium cyanide also, same results it will be. You will be getting RCN and NaX, you will be getting it. Alright. So in this way, what you find is that if I take here CH3Cl plus KCN, I will be getting CH3Cn plus KCl. Alright. So in this way, you will be getting, that is cyanides or nitriles. But what I was saying, you will be getting two different products, isn't it? Now see here, how different. If I take Rx, the same alkyl halide, but instead of KCN, if I take here AgCN, alright, AgCN, mind it, if I take here AgCN, this will be of course R plus X minus, no change here. But here, silver cyanide is not an ionic compound like potassium cyanide or sodium cyanide. Listen carefully. Silver cyanide is not an ionic compound just like potassium cyanide and sodium cyanide. It is a covalent compound. So here we have to do the charge separation on the basis of its electronegativity. So here nitrogen is more electronegative than carbon, then silver, you know that. So nitrogen will be more negative and silver will be positive compared to it. So hence we will get here AgX, no doubt about it. As you can see it here, AgX, I am getting positive, negative. But here this alkyl group will be attached to the nitrogen because nitrogen is more electronegative in nature. As you can see it here, alkyl group will attach to the nitrogen. Alright, here it was, carbon was what you can say electronegative. Because when it was dissociating, the negative charge was on the carbon atom. I don't say carbon is more electronegative, but the negative charge was on the carbon atom. Alright, Cn minus. Got it? So Cn minus. So as a result, alkyl group attached to this particular carbon atom. Because I've said you already that nitriles and isonitriles, they are ambident in nature. We can say that. They are ambident in nature. How can we say? See again, once again I am saying you. See here. Cyanide. So carbon is having 3 bonds. So this is one pair of electrons here. Nitrogen 3 bonds and one pair of electrons, you know that. Carbon is having altogether 4 bonds. Na? So 1, 2, 3 is present. So one pair of electron will be there. That means this is one bond. So here nitrogen is neutral because nitrogen is having 3 bonds and one pair of electrons, that is neutral. But here due to the presence of this pair of electron excess, carbon is negatively charged. Alright, if you see, that is when it arranges, because they form tautomers, cyanides and isocyanides, they form tautomers. Then what you get is that here carbon is having a pair of electrons, here nitrogen is having 2 pair of electrons. How nitrogen is having 2 pair of electrons here? Alright, how nitrogen has got 2 pair of electrons? Because here 2 bonds is there. So one bond will be 1 pair of electron, nitrogen, and one, of course, in neutral nitrogen atom we are having a lone pair. So you can see here nitrogen is having 2 pair of electrons. Alright, so due to which nitrogen is more electronegative than carbon. Nitrogen is more electronegative than carbon. Alright, due to this reason, what you find is that nitrogen is more electronegative, and hence here also same thing, that as nitrogen is more electronegative, so here the N is attached to alkyl group. Alright, understood this particular thing? Here the cyanide, due to the presence of pair of electron, the cyanide. Now you will say, sir, here also nitrogen is there. Yes, nitrogen, neutral nitrogen contains one lone pair, always. Always one lone pair is always there when nitrogen is neutral in nature. But when carbon is neutral in nature, it does not possess any lone pair of electrons. So hence you can see this carbon is having a lone pair. Due to the presence of lone pair, it is negative. And hence carbon is more electronegative in case of cyanides, in case of nitriles. So alkyl group get attached to what you can say cyanides, to the carbon atom. Fine. Now here you can see that nitrogen is more electronegative than carbon due to the presence of two lone pairs. So definitely the alkyl group get attached to the nitrogen atom. Got it? So hence what you find is that Rx, when it reacts with AgCN, it forms AgX plus RNC. It forms AgX plus RNC because R get attached to what you can say nitrogen, which finally get attached to carbon atom. So hence that is cyanide is or nitrile is the main product. Here isocyanide or isonitrile is the main product. Now here one more thing I said you. Now here you came to know they are ambident in nature. Once again I have explained you, they are ambident in nature. Because here the alkyl group can be attached to this carbon, here the alkyl group can be attached to this particular nitrogen atom. So hence it has got two donor atoms. Here carbon is a donor atom, here nitrogen is a donor atoms. Fine. Now what I said that it forms a major product. Generally what we see is that when the reaction is taking place, we are getting RCN as well as RNC. But as RCN is a major product, so hence in the reactions we write RCN. Alright, listen carefully. Here RCN and as well as RNC will be formed. So RCN is a major and RNC will be the minor product. Always we consider the major product. Major means around 95% this will be formed and RNC will be 5%. So hence we will not consider. Similarly here also same thing, that here this is 95% when we do the reaction to AgCN and RCN is around 5%, we can say that. Due to this reason, RNC we consider as a major product. Generally, this thing happens practically. Practically, this thing happens. But for theoretical purposes, I am explaining in this way. But practically, this thing happens. Two products is always found in both the reactions. But we always consider that particular product, which is a major product, so to say. Clear now? So in this way, we are getting two different products when it reacts with two different cyanides. As it is an ionic compound, so the reaction takes place in this way. As it is a covalent compound, so the reaction takes place in this particular manner, so to say. Alright, hence it is also proved that the cyanides and isocyanides, they are ambident in nature. They have got two different donor atoms, so to say. Now, next we can prepare it from amides, from acid amides. We can prepare it. So, how can you prepare from acid amides? See here, that is RCONH2. Alright, when it is hydrolyzed, RCONH2, when it undergoes hydrolysis. Alright, that is in one way we can do it, when it undergoes hydrolysis. Or, what we can do is that, if you remove the water, see here, H2 and O, if I remove it, then we can get RCN. Alright, so one aspect is that if I go for hydrolysis in presence of acidic medium, which you have already learnt it in acid chapter, I will tell you. Once again, let me tell you. So, what you will be getting it? RCOOH. Here, got it? And this particular product, what it forms? It forms ammonia. RCOH plus ammonia, it is being formed. Now, the drawback of this particular reaction is that this is a carboxylic acid, this is ammonia is basic in nature. So, acid and base will react together to form salt. Alright, it forms salt. That is the major drawback of this particular reaction. So, how to remove this particular drawback? As soon as acid is formed, you remove it. But we can't remove the acid. But as soon as the product is taking place, you allow the product to escape. Which will escape? Ammonia is going to escape. So hence, ammonia will not get further chance to react with acid. Understood what I said? You allow the product not to react with another. How will you allow? You allow the product to escape. When you allow the product to escape, ammonia escapes. It's a gas. So it does not get a chance to react with carboxylic acid further to form what you can say salt. Correct? But it's a drawback. So hence we generally won't do this particular reaction. Theoretically it is possible, practically also it is possible, but practically you need to see that ammonia is being removed. Fine. Now next, then what we can say, I said already that we can also remove water. How can you remove water? By taking any dehydrating agent like P2O5, I can take it. phosphorus pentoxide, we can say, by taking it upon heating P2O5. What will happen is that water will be removed, H2O, you can say that. This is removed, and what I get? I get RCN, alkyl cyanide. I get it. Clear? Alkyl cyanide, I get it in this particular way. Generally, we start in this particular manner. For example, we start in this way for this reaction. We take ammonium acetate, CH3CONH4. Now, this is an unstable compound. Ammonium acetate, I said, it's an unstable compound, so to say. Clear? So, upon heating slightly with P2O5, what will happen is that it will give you, that is CH3CONH2. See here 2 hydrogen and here one oxygen will be removed, and hence you get CH3CONH2. Water is removed, which further is being heated with P2O5 and heated, which further is heated with P2O5 to give you CH3CN plus water, which I have written here. We can say that. Yeah. So in this way we can get this particular reactions. Fine. So this is another method. From amides we can prepare, that is nitriles. Now we can also prepare it. By using aldoxyms. That is NOH, whose functional group is CH3CH double bond NOH. Now how to do? How to remove it? That is same thing, use a dehydrating agent. Because see, you have to keep in your mind, I want CH3CN. So CH3CN. So hence this hydrogen and this OH, if I remove it, it will be done. So here I can take P2O5 and heat it, I can take it, or I can also take, that is acetic anhydride. That also can be taken. What I have said? Acetic anhydride. As it is anhydride, it will love water. It wants a water molecule. What it will do? By taking a water molecule, it will become acetic acid. Anhydride will become hydrated. Alright. So we can take acetic anhydride or we can take P2O5. But I am going to get it CH3CN plus water. What is the name of this compound? CH3CH double bond NH. It is nothing but known as acetaldoxim. What I said? Acetaldoxim. In this way we can prepare ethane nitride. Now we can also prepare it from Grignard reagent. We can prepare it. How? Like RMgX plus ClCN. ClCN is what? Cyanogen chloride. Alright, in presence of dry ether, which acts as an inert solvent, dry ether. But I am going to get it, I am going to get, that is RCN. Same thing. C is negative here, so RCN. And hence, what is the other product? One bond with X already there, MgX, another bond will be with Cl. Because this is an halogen, this is another halogen. Maybe two same halogens also. This also can be Cl. So you will be getting MgCl2 plus RCN. This is the product I want. That is RCN. Alright, we can also prepare from amines. We can prepare it. Alright, and this particular reaction is very important. It is called as carbyl amine reaction. What I said? Carbyl amine reaction. Carbyl amine reaction is a very important reaction. Alright, so hence you will be taking here RNH2. You will be taking, plus you will take chloroform CHCl3 and KOH. You will be taking it. Alright, that is alcoholic KOH, which acts as a reducing agent. Remember, alcohol when it is there means it acts as a reducing agent. Alright, so what I am going to get it here? I am going to get here RNC. See, this is a carbylamine plus KCl plus water. I will be getting it. So that is to balance it. Here 3 chlorine is there, so I want 3K, and so that I will get 3KCl, and as a result I will get 3OH and 3 hydrogen, means it is nothing but, what is that? 3 water. I will be getting it in this way. So what I find is that I got RNC, which is called as carbylamine in this way. So carbylamine, which is highly poisonous compound, it's a highly poisonous gas, so to say, it is being absorbed in the skin. It's highly poisonous, this particular reaction is. Alright, but it's a very important reaction. In this way the carbylamine can be prepared. So in this way, these are the different methods of preparation of nitriles and isonitriles, so to say. Thank you.